Okay. So this is our test 2 study session for CIT 247. I want to start this by saying that this test is not going to be terribly long. It's going to be pretty short, like the first test, not like the midterm where there was a bunch of short answer questions. It's going to be quite a bit more like the test 1. But anyway, this is, as you can see, this is a pretty short, this is a really short study guide here I made in PowerPoint. So there isn't a ton of content to go over, but I want to make sure you all have a good handle on everything that's going to be in the test. So let's go ahead and begin. So here's an overview of the exam. Test 2 consists of a traditional Canvas exam and 2 hands-on GNS labs. As I said, this test, like the quiz portion of the exam, is going to be a lot like the first test. It's going to have multiple choice questions, a few fill in the blanks, and it's going to have some short answer questions. So it's not going to be like the midterm where it was a bunch of short answer questions only. This test is actually going to have some multiple choice questions. What is different from test 1, however, is that these are actually based on the textbook because they are about OSPF. So you all actually didn't get an OSPF quiz. So I actually designed the test, and what I based it on were the first 2 chapters of OSPF in the your CCNA book, the textbook for this class. If you give me just a second, I'll quickly look up the chapter numbers. Let's see. So chapters 19 and 20 will have a lot of the questions you'll receive. There will be some that won't be in the textbook, but they'll be pretty similar. And everything, just about every multiple choice question in this exam, you could find the information you need to understand in this PowerPoint for the multiple choice questions. So I would highly recommend you pay very, very close attention to the OSPF portions of this PowerPoint. It's a little hint. So in addition to 10 multiple choice questions, there's also 8 fill in the blank subnetting questions. They should be similar to the subnetting questions in the practice quizzes. Like the format might be a little different, but the questions are pretty much the same style. Like you're given a map or an IP address and a mask, depending on the kind of question it is. But anyway, these questions will include 2 subnetting questions where you'll find 2 sub IDs, 2 questions asking you to find broadcast addresses, 2 CIDR mask conversions. So these are basically like the questions in the no practice subnetting module where it has like mask conversion. That's what these questions are. And then finally, 2 questions on wildcard masks. I don't believe you've had quizzes on those, but I will show you how to do that in this module. You've probably already been working with wildcard masks and are proficient with them in your studies in OSPF. But anyway, I want to emphasize there's no maximum subnet/host questions. I did not add any of those to this exam, so you don't need to worry about those. In addition to these 18 questions are another 8 questions with VLSM. These again will be similar to the network design quiz. Now I want to give a hint. The network design quiz has been open to allow infinite retakes. Practice that exam over and over again. That's what I highly recommend you do to practice or to prepare yourself for the VLSM questions. Practice those over and over and over again until you get really good at them. And then finally, there's 4 short answer questions. These will be relatively basic. They'll cover the topics they'll cover include network routes, OSPF, VLSM, and subnetting. So basically, there's going to be a question I'll ask you I'll ask you to answer a few questions about network routes. There will be one on. Oh, did I break up? I think it may have. Let me repeat that. So the four short answer questions include working, or it'll ask one question will ask you a few questions about network routes. Another one will actually ask you to configure OSPF. Okay, thank you. Another question will actually give you a VLSM question. And then finally, there's a subnetting question similar to the midterm exam. So that's pretty much all there is in the quiz portion of the exam. It's nothing terribly hard. But anyway, to prepare for this exam, I highly recommend you go through the practice questions at the beginning. There's no quiz for this, but the beginning of the first 2 OSPF chapters in the textbook, specifically chapters 19 and 20, you will find a bunch of practice questions. You can actually find the answers to these questions about 2 pages after. Memorize the answers to these questions. I will warn you, they may not necessarily be, the questions may not necessarily be ordered in the same way you see in the textbook, so keep that in mind. Don't memorize the order, memorize the answer. Second, I would highly recommend you practice your subnetting quizzes and also the network design quiz. That's going to be crucial if you're not very good at VLSM. You need to practice it. Um, then I would recommend you can go through Canvas PowerPoints and you have time lectures. That can help you with some of these key aspects of the exam. Now, this PowerPoint also contains just about everything you need to know for the exam. It might have everything actually, but make sure you also study the key topics in the textbook, PowerPoints, and lectures if you have time. If you don't, that's if you don't feel particularly confident in a certain area. And GNS, there's two GNS labs in this exam. One of them is both of them deal with routers. The first one has you set up static routes. So you need to go back to your first, I would recommend going back to the first lab that dealt with routers and practice your static routes. These GNS quizzes or GNS assignments are completely open book. So feel free to use your command guides, the internet, textbook, and your notes to finish them. Also, I highly recommend, once again, do copy our UST. Please make sure you save your work before submitting the thing. And also, I highly recommend re-downloading your lab after submitting it and testing it to make sure everything works. So this is especially helpful to determine if your configurations were saved with the thing. If you download your lab and it has nothing, that means I'm going to see nothing, and that's not going to be very good for you. So I highly recommend after submitting your lab, re-download it, make sure everything is on the up and up, and if everything is, then you won't have anything to worry about. So let's begin with studying topics in the exam. Sources of routes. This will be important for one of the short answer questions. So there are three types of routes. There's connected, which are created when an adjacent router, when two, I'm sorry about that. When two adjacent router interfaces have IP addresses configured and have the no shutdown command configured. So basically all you need to do to create connected routes is add an IP address and subnet mask to two adjacent router interfaces and then enable them. Static routes are created manually by the administrator. You can look back at the command in Canvas if you wish, or one of my lectures. But anyway, basically all you need to do is type in subnet ID, the subnet mask, and then the next hop interface or the outgoing interface on the router you're configuring to get to that destination. Finally, there are routing protocols. These routes are created automatically after the administrator sets up a routing protocol on the router. So examples of routing protocols include OSPF, or might be important for one of the questions in the exam, by the way. So let's do an overview on OSPF. So open shortest first path is or OSPF is a widely used routing protocol that helps routers automatically learn each other's routes. The following are some facts concerning the protocol. Now, make sure you understand these facts when you go to the exam. They'll be pretty important. So OSPF uses link state logic as a metric to choose the best or fastest path available to a specific subnet. So like EIGRP, eGRIP, I guess, OSPF's metric is at least partially affected by link bandwidth. So along with RIPv2 and eGRIP, the OSPF protocol is also compatible with VLSM. OSPF allows routers to inform one another about available routes through link state advertisements or LSAs, which advertise the routes created from network commands. So OSPF utilizes a concept known as areas, which divide networks into two sets of routers that share LSAs in order to reduce bandwidth consumption from OSPF processes. So in other words, areas basically create divisions in like a big network, internet or company network. It divides them into areas. The reason we do that is to save on bandwidth because OSPF has to use LSAs to communicate routes to one another. And if every router in a large company is doing that, I mean, you're taking up a lot of bandwidth. So that's why areas are done. That's why we use OSPF areas. However, there is an advantage of single area OSPF. It's better for small companies. But anyway, single area OSPF has one advantage. It allows for simpler planning and operations. So OSPF also allows for further bandwidth savings through the use of passive interfaces, which prevent certain interfaces from sending or processing OSPF hello messages. So basically, in your labs, you would implement passive interfaces to computers or interfaces that lead directly to computers. The reason you do that is because you don't want to waste bandwidth sending LSAs to a device that's not going to create OSPF routes. So that's why we implement passive interfaces. So basically, you would use a passive interface on anything that leads to a switch that's not connected to any routes. But that also is true for direct ports that directly lead to a computer or printer or anything like that. But if an OSPF or if an OSPF router is connected to a switch and that switch is connected to routers, other route directly connected to other routers using OSPF, then you will not want to use passive interfaces or implement passive interfaces on those ports. So here's a little review of the OSPF commands you'll need to use in your labs. You may also need, keep in mind, you may also need to know these for the exam. So configuring OSPF, you do configure, you enter global configuration mode. You type router OSPF1. Any process number works, but OSPF1 is typically good. So then you use network commands. So you type the word network, you type in the subnet ID, you type in that subnet's wildcard mask. So basically that's basically the inverse of the subnet mask used for the subnet. Then you type the word area, and then you type in area number. So in addition, you can implement passive interfaces by using the command passive/interface, and then interface name might be like I'm sorry, that would be like FA0/1. I'm sorry about that. But here's some examples of some network commands. So you can see the 192.168.0.0 subnet there. You have wildcard mask or /30 mask and then area 1. Then there's also another example. So those are some examples of network commands for OSPF. So here's some show commands for checking OSPF configurations. So for example, there's show IP protocol. That's a very important command. You'll be using that a lot in CIT 447. But anyway, show IP protocol shows your OSPF configurations, including the routes and passive interfaces you configured for the router. So basically, when you type in show IP OSPF or show IP protocol, you're going to see the network commands you actually typed in to that router. You're not going to see the other routes, but you'll see the routes you configured specifically for that router to advertise. Then there's the show IP route command, which shows the OSP routes that the router learned from other routers. An important point to note about the show IP route, show IP route command is that it will not show OSPF routes advertised by the router the command is typed on. So in other words, these commands you typed here, like the network commands, you're not going to see these routes on your routing table you configure these commands for. So that's all there really is to OSPF. Now, an important part or a big part of this exam is going to be subnetting. So it's very important you understand how to do the subnetting processes. So I know some of you do the binary method for subnetting. That's fine if you wish to do so. I personally am not very familiar with the binary, and I typically explain the magic number method. It's honestly the method I recommend because it's typically, I mean, depending how good you are binary, I mean, magic number method typically is faster. If you want to use binary, that's fine. But if you want to take the time to learn the magic number method, I recommend doing so now. Honestly, it makes VLSM a lot easier. So it's honestly this process and this slide right here is incredibly important. So so there's 4 basic steps to finding a sub ID when you're given like an IP address and a mask. So the first step is to examine the CIDR prefix, then use the subnet mask to format the normal octets and find the interesting octet. So the main goal of the magic number method, or one of the main premises of it, is that typically you only really need to do math on one octet. Basically, that's one of the in case you don't know, it's one of the sets of 4 numbers. So basically, when you have an IP address like 192.168, the numbers between the dots are the octets. And we're trying to find the interesting octet with magic number method. In other words, that's the one we need to do decimal math on. So basically, you write out the dot decimal notation of the CIDR mask you receive. So if you get like a /24, for example, that would be 255.255.255. If you got a /25, that'd be 3 sets of 255, but that would also be 128. The last octet would be 128. So in that case, So you would actually copy those portions of the IP address over to the sub ID. What that means is that if you have an IP address of 192.168.1.0 and your subnet mask is /25, you will copy over to sub ID 192.168.1, and then the interesting octet would be the fourth one. You don't know, in other words, you won't know what that is yet. Now, if an octet in IP address is 0, you basically just put 0 in that portion of the sub ID. However, if an octet is neither 0 or 255, it is the interesting octet, and we need to solve for that number. So in our example here of /25 with 192.168.1.0, the interesting octet would be the fourth one. So we don't know what that is, and we need to solve for that number. How we solve for that number is finding a magic number. It is found by subtracting the number of the subnet mask's interesting octet from 256. An example given here is 256 minus 252 equals 4. But in the example I'm demonstrating, which is /25, so 128 is the number in the interesting octet. So if you subtract 256 from 128, we get 128. So that would be the magic number. So next is to find the magic number, is to find the multiple of the magic number that is closest to the interesting octet in the IP address without exceeding that value. So it's important to note that this number cannot be larger than the number in the interesting octet. So let's say we have an IP address of 192.168.1.200, and our magic number is 128. Basically, we need to find the multiple of the magic number that either equals or is closest to that number. We cannot exceed that value. So if we have 200 and the magic number is 128, the first multiple of 128 is, well, 128. The second multiple is 256, which isn't a valid IP address number. So with this method, we now find that our subnet is 192.168.1.128. So after you solve for that number, like I just did, you just place that number, that multiple of the magic number, in the interesting octet of the sub ID. And that is how you solve for these problems. Now, if you need more information on this or want a table to demonstrate this process, in the no credit subnetting practice module in Canvas, I have another PowerPoint that goes over all of these subnetting problems, like the sub IDs, broadcast addresses, and the maximum minimum hosts. With that last one, you won't even deal with it in this quiz anyway, but that's just to let you know that. So broadcast addresses. So basically the process is very similar, but there are a few key differences. Many of the steps are actually copied over. So unlike finding sub IDs, if an octet in the IP address is 255, or in other words, the octet over the octet in the subnet mask is 255, you copy that number from the IP address over to the broadcast address. That's actually the same, I apologize. But if that number is 0 in the mask, 255, the number 255 is put in that portion of the broadcast address. Again, if neither 255 or 0 are in an octet, that means it's the interesting octet, and we need to solve for that number. So the magic number method is still the same. And also you're finding a multiple of the magic number that's closest to the interesting octet, just like the subnet ID. So basically, to find the broadcast address, you need to solve for the subnet ID first. So after you do that, you take the multiple of the magic number you solved for, you add the magic number to it, and then subtract from 1. So in our example of 192.168.1.200 with the subnet mask of 255.255.255.128, magic number is 128, and the multiple, basically that number itself is the multiple we need, because 256 is bigger than 200. However, to find the broadcast address, we would take 128, we would add it to itself, so that'd be 128 plus 128, and then subtract 1 from it. So that would be 255. So our broadcast address would be 192.168.1.255. So basically, that's how you solve for broadcast addresses and subnet IDs. It's not terribly hard, the broadcast or the magic number method. It takes some practice, but once you get good at it, it helps you go really fast with these problems. And I honestly recommend it for the VLSM questions, because honestly, they're based off of multiples of these magic numbers. And it makes solving these problems a lot easier. So, excuse me. So your third subnetting problem in the exam is going to deal with CIDR mask conversions. So I have a table here. This table can be helpful for studying other components in the for the exam, like the magic numbers that go with the CIDR masks you get, and also the dot decimal notation and interesting octet you'll get when dealing with these CIDR masks, or when you get these CIDR masks. And also for others who use binary, also include binary. But this table is also very important for solving CIDR mask problems. So here's an example of how to convert a CIDR mask to dot decimal notation. So we have in this example /19. The first step is to determine the subnet class to determine the number of 255s in the mask. So for example, I give you all the 2/8/15 will have one set of 255. That means there's 8 network bits. Class B will be between /16 and /23. It'll have 2 sets of 255 because it has 16 network bits. Finally, class C is between /24 and /30, and there will be 3 sets of 255 because there's 24 network bits. /19 is a class B address, therefore there's 2 sets of 255. So then you need to determine the number that belongs in an interesting octet. This octet comes right after the last 255. So basically, the best way to determine this is to memorize. So there is a pattern. So in this little box here, I wrote, notice the pattern with the interesting octet numbers in the class of CIDR masks. So the first classless masks are /9, /17, and /25. And the very first magic number that goes with these masks is 128. So there's a mathematical pattern that goes with every set of masks. So starting from after /16, you have /17. The interesting octet would be 128. /18, the interesting octet is 192. /19, the interesting octet is 224. So the final octet after the interesting one, or final octets, will have a 0. So /19, when using this method, is translated to 255.224.0 in dot decimal notation. So I recommend studying this slide if you haven't done this much, because you'll need to do this in the exam. So subnetting wildcard mask problems. So I don't think you received any problems that are written out like this yet, but this table and this slide will really help you out here. It's honestly really simple. All you do is take 4 sets of 255, and then you subtract the dot decimal notation of the subnet mask from this number, and then you get your mask. So for example, here we have 255.255.252.0. So basically, you take that, you subtract it from this number here, this set of 4 255s. Then 255 minus 255 is 0. Basically, just do basic math here. So 255 minus 255 is 0 here. 255 minus 252 is 3. And then 255 minus 0 is 255. So that's basically all you need to do to compute wildcard masks. Yeah, the test, I will stress that both the GNS labs and the quiz portion of the exam will require you to know how to do this, just to let you know. And also, if you do binary, I included it here. That's in case you want to do the binary. Honestly, this subtraction method is a lot easier, so it's up to you what way you want to solve it. But okay, we're finally at probably going to be the most difficult part of the exam, VLSM. Now, it'll be difficult if you don't know how to do this, but if you take the time to learn the magic number method and you know what you're looking for, these actually become really easy, I will tell you. These can actually be pretty easy if you know what you're doing. So I give 2 questions for you to practice with. I'll let you all practice with the second one in your own time, but we're going to do this first one because I have the example written down that gives a better visual example. So you've encountered problems like this in the network design quiz. So this problem gives us using a /20 mask in this 172.16.0.0 class file address space. The lowest possible subnet number is 172.16.0.0/20. List the next 3 lowest subnet numbers after that in order. So basically, as I said, this basically requires you to use the multiple of the magic number. So when you're given this problem, here's a solution. Here's some steps you can follow. So in this example, we're going to use 172.16.0.0/20. we're going to first write down the next three lowest subnets, or that's what we need to do. To solve, first find the magic number from the subnet. So there's a pattern for magic numbers. It's 128, 16, 32, 16, 8, 4, 2, and 1. So basically, this pattern starts after the first mask that follows a class /8. So this would be the magic number for /9 would be 128. And then you have /17 after /16. /17 would also start with 128 as the magic number. So using this knowledge here, we have /20. So let's start counting from /17, which is 128, /18, which is 64, let me see, 17, 18, /19 with 32 is /20 with a magic number of 16. So use the magic number to write down the next subnets by placing the multiples of the magic number in the interesting octet. So you next need to figure out what the interesting octet is. You can't just put it right next to the 16 here in this address. You need to make sure you know where you need to make sure the mask permits you to put it in a certain place. So you do that by figuring out where the interesting octet would be. So the interesting octet is determined by the class of the mask. So for example, if the mask is class A, the second octet will be the interesting one. If it's a class B address, the third octet will be the interesting one. Finally, the class C ones have the interesting octet and the fourth octet. Now, /20 comes between /16 and /23, therefore it is a class B address. So your multiples of the magic number are going to go in the third octet. So there's 16. So you starting from 0, 16 times 1 is 16, 16 times 2 is 32, 16 times 3 is 48. So that's basically all there is to doing this. It's figuring out the magic number, figuring out the interesting octet, and then doing some simple multiplication. Honestly, it could even be addition, depending on how you want to solve it. Now, Ben, I know you're here. I want to ask you, does any of this make sense to you? You can just type your answer in the chat. But does this make sense to you? That's very good. Thank you, Ben. So that's all there really is to solving the next three of those subnet problems of VLSN. It's actually quite simple if you know what you're doing. And the magic number method, as I said multiple times, is very, very helpful here. So again, I leave another problem for you to for you all to practice in your own time. You can do it right next to this example. But I'm going to solve this one, which is demonstrated here. So you've also had these problems where you need to add a new subnet to an existing design. So you're given this problem. The following subnets exist on the router. So you're given a bunch of subnet masks. And then you're asked to add a new /20 subnet in this list. So using this classful address or classful network, what is the lowest possible subnet that you can use? So with this address and mask, you need to find the broadcast. So excuse me a minute, let me start over. So these are the steps you can use to figure this out. It's another 3 steps. But basically, what these problems involve is finding the broadcast addresses. The reason you want to do that, it helps you determine the range of addresses a subnet encompasses. So we're taking the address that we want to, we're taking the subnet mask and address that we want to add to this list. So we find that /20 in this classful address space goes from 172.16.0.0 to 172.16.15.255. So that's the broadcast address. So basically, you can count here and see that there's a range of 16 numbers from the interesting octet. So it goes from 0 to 15, counting. That's the range of addresses that can be in this subnet. So for example, in this address, you can actually assign a computer. So the computers, the address is like 172.16.1.10 or 172.16.14.200 or 172.16.3.5. So all those numbers will fit in this range here that you see right here. So I already explained this part, so I'll say it again. So note the number range that is encompassed by the interesting octet. It is 16. So we need to find a place in the given list where the subnet can begin with a multiple of 16 in the interesting octet and not overlap with another subnet. So that's an important thing. We want to make sure we don't overlap with these subnets in this list. So the next step is to find the broadcast addresses of the other subnets in the list. So you can either do this in your head with the magic number method, or you can write it down on paper. We'll give you enough time to do so in the exam. So basically write down all the broadcast addresses from the list. And then with this list here and knowing this range here at the top, Your third and final step is to find the lowest possible subnet number that can fit in this list. So basically, you can write down ranges. So 172.16.0 to this broadcast address here, and you can keep repeating this, starting with a new subnet, starting with that starts with another multiple of the interesting or the magic number. Sorry. But anyway, we find that this range here does not work because it overlaps with this subnet. If you look here, 0.0.0 is already taken with this mask, or it was taken with this subnet here. So we can't use that. We can't use that subnet with this. We can't use the first range in the subnet. So the second subnet from this subnet mask in classified address space is 172.16.16.0, and it goes to 30.31 to 255. It also doesn't work because this address space is actually already taken up by the third address in this list. So the next available one is 172.16.32.0. We're doing multiples of 16 to 172.16.47.255. This does work because there's no overlaps. You notice here that this subnet, the third one, ends on .31, and this new one begins at 32. Notice how this one ends. Notice how this one ends at .47, and the next subnet in the list ends in or begins at .64. So therefore, there's no overlap, and that mask works. That would be your answer. 172.16.32.0 would be your answer. So that's basically how you solve for these problems. You just need to make sure that you just need to write a new subnet using the magic number from this mask, making sure that whatever subnet you pick does not overlap with any numbers in the list. So that's basically it to the study session. It wasn't a whole lot, but this guide is actually already on campus for all of you to, or Canvas, sorry. It's already available on Canvas for you all to review. And I will upload this review video as soon as I can. It should be open or available later today. But anyway, Ben, do you have any questions about anything? Okay. Okay, I'm going to stop the recording now. Thank you all for watching the study session. I wish you the best of luck on test 2.